Okay, so now we'd like to continue to understand how to use F equals MA. Just with simple examples, what are the important things to continue to consider? So in the previous video, I gave an example where we had just two forces and one was acting there, 5, and one was acting there, 3, like that. And I was saying, and we saw that basically the 5 Newton force will overpower the 3 Newton force. And if we want to calculate the acceleration, we subtracted 5 minus 3 is equal to the mass times the acceleration. So 2 equals 2a, and the acceleration we got was 1. But what if I added a few more forces? What if someone was pushing here with a 10 Newton force, and someone was pushing here with a 12 Newton force, and maybe there was someone pushing there with a 20 Newton force? How could you simplify this, and how could you figure out which direction that the object is moving on? So one way to do this is to take one direction as positive and pick another direction as negative. So if I picked all the forces pushing this object forwards as positive and these as negative, why do I do this? It's because these are trying to fight against these other forces here. They are opposing them. So basically 20 plus 5 plus 10, these forces are working together. And then the minus 3 and the minus 12 are opposing those other forces. So the force, this will be the total force, each and every force acting on the object, is equal to the mass times the acceleration. So which is equal to, what's the mass? 2 times the acceleration. So if we try to calculate this, 20 plus 5 plus 10 is 35 minus 15 is equal to 2a. So 20 is equal to 2a. So 10 is equal to a. And what direction is this object going to move in? Well, this time we're going to think about which of the sides had more force. So this was 25 and 10. That gave us a sum of 35. And this was negative 3 and negative 12. That gave us a sum of 15 or negative 15. And so clearly the 35, the ones on this side are stronger than the ones on that side. And so they're going to manage to push the object in that direction with an acceleration of 10. But there's another way you could think of this. This term is positive, and when we're starting out, we picked all the forces in that direction to be positive. So you could also take it that the fact that you've got a positive answer shows you that the acceleration is supposed to be in the same direction as these positive forces. Yeah. Now here we've been working on questions where everything is in a single dimension. What if I decided to do something like this? If I added a 5 Newton force right there, then we had 10 Newton force right there. What would be the effect of this? F equals ma. I have been saying that F considers all the forces acting on an object. But there's an important point I forgot to add, or that I waited till now to add. It's the fact that F does consider all the forces acting on the object, but when we're working with F equals ma, we must only consider a single parallel direction. What do I mean by like that? We should only consider the forces acting along that line. You could think of it as that, parallel to that line. So all the forces acting like that, maybe, all the forces acting backwards, all the forces going there, all the forces going there, all the forces going there. But the forces going in another direction, if the force is going in a slightly different direction, like these ones here, these are not parallel to this straight line. They're not parallel to the straight line. So we will not consider them when working with F equals ma. In other words, what I'm trying to say is that when we're working with F equals ma and we have all these forces, 5, 3, and then 2, we are going to initially only consider the 5 and 3 together. When working with the 5 and 3, we will not include the 2. But the 2 can also be used in the F equals ma equation. It can also be used in the Newton's second law equation. But what are the conditions for us to use it? Well, just as we've said, these forces that are working together, they're kind of like in a straight line. Yeah. So what we're working with the 2 Newton force should also kind of sort of be in a straight line or parallel to the 2 Newton force. So what force could work with the 2 Newton force? Possibly, and if there was a 2 Newton force here, possibly if there was another force here acting, pushing together with the 2 Newton force in the same direction. Or if there was another force acting upwards like this, which we'll look at a little bit later called the reaction force R. Maybe a 7 Newton force right there acting against the 2 and 5 Newton forces. But as you can see, these are all acting either directly upwards or directly downwards. Or we'll look further at stuff like slopes. So we can work with all the forces working there and there and there. We can work with all those in the same F equals ma equation. Or maybe if you had another slope like that, we can work with the forces acting there and there and there. We can use them all in the same F equals ma equation. The important thing is that are they pointing in the same direction? And that's part of the important thing that we have to consider.